Welcome to Statistics in Excel video number 51. Hey, if you want to download this workbook and follow along, click on my YouTube channel and click on my college website link, and you can download the workbook, Business 210, Chapter 4. If you're in the class, just go to our Chapter 4 website. Hey, in the last video, we talked about the basics of probability, and we were looking at handwritten notes, PDF file. Here we want to talk about the basics in Excel. Now, we're going to consider an experiment of tossing a coin 3 times. Now, let's remind ourselves what in the world an experiment is. 1, it means 2 or more possible outcomes. 2, it is uncertain which will occur. And 3, on any single repetition of the experiment, 1 and only one of the possible outcomes can occur. That is why in last video we saw that the sum of all of the probabilities associated with the sample points equals 1, because on any given trial of the experiment or step, 1 and only one of the possible outcomes can occur. Okay, so steps. We have 3 steps because we're going to flip the coin 3 times. Outcome on step 1, 2, and 3, each 2, 2, 2. So we can get head, tail, head, tail, head, tail. Total experimental outcomes, as we saw in the last video, the formula is just multiply all of the outcomes on each step. So we just need to take the product of 1, 2, 3 number 2s. Now, again, in this example, the outcomes are the same on each step. Sometimes they're not. Here's one way to do this. We'll use the product function. Product function just takes all of the inputs as a range and multiplies them. So when I hit enter, I get 8. 8 total sample points in our sample space. Remember, the sample space is all of the sample points. Now, when we flip a coin 3 times, is that classical, relative frequency, or subjective? It is classical. So guess what? We can just, because they're equally likely, each one of the sample points to get it, we just simply take equals 1 divided by the total count. And there we get it, 0.125 for the sample points. As we will see later when we calculate the probability of rolling a I'm sorry, not rolling a 2, flipping a coin. When we ask what is the probability of getting 2 heads in 3 tries, we'll see it's not actually 0.125. And that will come from our definition of event. Hey, now what I would like to do is construct a table. So I'm going to scroll down here and I have this little table set up. We have a list of 1 to 8. And I want to list the entire sample space. So for the first possible outcome, I want to list what we get on toss 1, 2, and 3. And then for the second sample point, I want to type out what we get on toss 1, 2, 3. Then I want to list the sample points. Then I want to calculate the probability. Now, this is a little bit of brute force. We're just going to have to kind of, unlike the tree diagram, which we saw last video and we'll see again in this video, this method is not quite as easy to list them all up, but we're going to try it anyway. So let's say we get a head, and then a head, and then a head. Why don't I put cap locks on? Okay. And then on the second one, we're done with head, head, head. Now we want to go to head and get 1 tail. So I'm going to type a tail here. And then whoops, that's called autocomplete when it does that. That's terrible. Head, and then head. Now, that tail's right there, so I'm going to put the tail right now and then put a head right here and right here. And now I got a tail there and a tail there, so I'm going to get a tail here. And then I can't not type today. This is terrible. Notice this autocomplete, what it's doing is it's looking up there. I can just hit delete now, and then that will work. And then I want a head here and a head here. Now, I'm done with all of the get 1 tail or 2 head and 2 heads. Now I'm on to 2 tails. So I'm going to type tail, tail, head. Now I'm going to put the head right here and put a tail right here. I know it's kind of a convoluted way to do it, but it'll help us in this table format calculating probabilities. So we have we need a head here too. T, T. Now I know, totally cumbersome, but the last one's easy. We know it's all tails, right? So I'll just put a tail. Notice I've highlighted all the cells in advance, so I just hit Control Enter. Now, to list our sample points in with the syntax that they use in this textbook, we could just go like this. Open parentheses, and then head, comma, head, comma, head, and then, oh, I can't type. Head, comma, head, comma, head, and then close parentheses. Oh, I can't type at all. I'm glad you guys are laughing because I am too. Okay, there we go. Oh, that is painful to do it by hand. You're welcome on your homework to do it by hand or the test, but let me just show you a formula that will work. Now, you remember from frequency distributions when we used our count if function, we looked at the ampersand, and shift 7 is the ampersand. That is the join symbol. So you can join different cell contents together, and you can join cell content with text. Here's how it works. We want open parentheses, so I'm going to type in equals, and we're going to have to put in double quotes, and then an open parentheses, and then double quote. Right? That's the first thing. If we were to hit Control Enter right now, you could see that's a ridiculous formula. It just puts a character in there. I'm going to hit F2. But now we use the ampersand. And we click on this H right here. Now, so far, if I Control Enter, you see I have joined some text and cell content. Now I can keep doing this, ampersand, and then what do I want? I want a comma and a space, so in double quotes, comma, space, and double quote. Notice anything that goes in is like a word or spaces or symbols has to be in double quotes. And then ampersand, I click right there. And notice now if I Control Enter, I got the H, comma, H. I hit F2 again, and I continue the sequence. I need one more comma and a space in double quotes. And then I get my H. And finally, I can ampersand, and then in double quotes put a close parentheses. Now that's hard to do, and it takes practice to do that, but and you're not required to do it on the test. You can type it out. But if you know how to do it and you can do it quickly, it's a lot faster, because then you can just double click and send it down, and it lists all of the sample points for our sample space. So when you come down here and hit the F2 key, you can see those relative cell references worked. Now, a word for those of you in the class too, you have the homework samples and some of these workbooks. The workbooks are just filled with text. These are called text formulas, and they're really quite handy when you're doing all sorts of things. That is one example. All right, now those are all our sample points that make up our sample space. Now I'd like to calculate the probability for each one sample point. And the way you do that, oh yeah, they're all equal and likely. So I'm going to highlight all the cells and type equals 1 divided by, and I'm very carefully going to click on that cell right there, the count, and hit the F4 key. Now I can populate that formula into all these cells by hitting Control Enter. Now the next step in this is to count the number of heads. Now again, you could just do it. We could see 3 there, and then 2 there, etc. But there's a simple formula. We used this before in Chapter 2 when you're doing frequency distributions. Count if equals count if. And notice what we're going to define as a success, meaning is heads. So when we get a heads, that's considered a success. We equally could have done tails, and then later when we talk about the binomial distribution, we'll be dealing nothing but successes and not successes. But we're defining success as a head. Notation is going to be an H, and there it is. So I do count if. I'm going to highlight this range, and what does that mean? That means relative cell reference. So as I copy it down, those dancing ants will move relatively, comma, and then the criteria, I'm going to click on this H, and then I'm going to hit the F4 key, right? And then close parentheses. That formula will work all the way down, Control Enter. I can come down to the bottom, hit F2, and check to see if I got it right. The green one's there, and the blue one's there. So there it is. We got 3 heads, and then a 2, a 2, a 2, a 1, a 1, a 1, and a 0. Now, ultimately, we're trying to calculate the probability of getting 2 heads in 3 tosses, or 1 head in 3 tosses, or 3 heads, or 0 heads. Those are all the possible possibilities. Later we'll see this denoted as x. That's a random variable. So randomly we could get this. Every time we do try this, we can either get what? 0 heads, 1, 2, or 3. That's it. Those are the x values that are possible. Now, I want to calculate the frequency. Well, here's all of the, for all of our sample points, our sample space, that's all of the number of heads we got. So we can come over here. We have all of our x's there. We can say equals COUNTIF again. The whole range is all of these. And then I'm going to hit the F4 key to lock it, comma, and what is my criteria? Right here, just as we did in Chapter 2, frequency distribution. All right, and then Control Enter, and I come down here, and I can see I have a problem with my formula right there. But I'm checking to see if my formula is working right there, and sure enough, it is. The green one's there, and the blue one is there. Now I want to add all of these up right here. So how do I do it? Because I'm checking. I better get 8 when I do this. Whoops. Hit Alt equals instead of, or I don't know, I guess I hit Control. What did I hit? I don't know what I did there. I'm going to use the keyboard shortcut to add Alt equals. Sure enough, I get 8. And there is our formula, right? We have 3 successes because this is classical probability divided by 8 for 2 and for 1. Just as we got over here, there's 3 of them. 3 of them divided by 8, that'll give us our probability. So we can do our relative frequency, which we already saw how to do this before, right? I'm going to highlight the whole range, and in the active cell, I'm going to say 2 cells to my left divided by this 8, and I'm going to hit the F4 key. Control Enter. And there it is. Now we have not only our sample space over here with all of our sample points and all the individual probabilities for each sample point, but now we've organized it in perhaps an even a better way, because now we can ask the question, what's the probability of rolling 2 heads and 3 ties? And there it is, 0.375. Now I'm going to list these over here. And by the way, an event, we'll remind ourselves from last video, is a collection of 1 or more sample points. 1 or more. Here we had how many for 2? We had 3 sample points. So because it's classical, we did 3 divided by 8 and got that. So collection of 1 or more sample points. And the probability of an event, sum of all the probabilities of the sample points in the event. Well, that's just what we did there. Now, notice we used the classical method. We equally could have added these up. Let's just do that over here to prove to ourselves. I'm going to Alt equals, and I'm going to scroll over here to the sample points. And there's only one of them. It's right there. I'm going to hit Tab. Now, for this one, 2, we got 2 heads and 3 times. I'm going to Alt equals, which is adding them all up. And I'm going to come over here and I'm going to add 1, 2, 3. So I'm going to add these ones right here and then tab. This is the strict definition of calculating a probability, is getting all of the probabilities associated with all of the sample points. And since there were 3 sample points, that's just an alternative way to do it. And that way will be helpful because we won't always be doing have this classical method where all the everything is equally likely. All right, let's list everything down here because I want to make a little chart and portray this visually. Here's the probability that I get 3 heads in 3 tosses, probability to get 2 heads in 3 tosses. All right, I'm going to highlight all these and type equals in the active cell and click right there. Control Enter to populate them. And I'm going to type probability here. Now, before we make our little chart, I'm going to go ahead and we saw the 2 requirements last chapter for probabilities. And what were they? Requirement number 1 was that each individual probability is between 0 and 1. Do all of these meet that requirement? You bet. The second requirement was that the sum of all the probabilities are equal to 1. Let's go ahead and test it. Alt equals, and we get 1. Notice that that also works over here. These are all the we've organized that the same total number of probabilities here in these events. But we could test this over here also. Alt equals, because remember, all of the probabilities associated with all these sample points have to equal 1. And there it is, 1. So both of these requirements are met. We're on the right track. Now I'm going to highlight this, and I'm going to go to Insert Column. Oh, but I could do that and then that one right there. But there's a keyboard shortcut for the default chart, which mine is column. It's Alt F1. And just like that, look what we get. I'm going to click right here and delete that. We get our nice little labels that I put right there, so we see clearly that those are probabilities. Let's do a few things to this. First, let's see if we can change this chart title. And I think I want to link it to this one up here. You could easily just type it. But watch this. That is selected. I come up here to the formula bar, type equals, and then I can scroll over, just as we saw before. And I'm going to click on A1. Notice it says A1 and then enter. Oh, look at that. It's linked to that cell. I'd like to click here, and then I would like to go up to Layout, Data Labels, and then Outside End. And so now we have our probabilities. I'm going to click on these lines. We don't really need those lines. When you see those highlighted, I can hit the Delete key. And I want to add a label here. This is pretty self-explanatory. Actually, no, let's add 2 labels. Let's go out to Layout, and I'm going to go to Axis Titles, and I'm going to go to Horizontal, and then I'm going to click Title below Axis, and I'm just going to type the word Event. Notice it's highlighted. I'm not going to click up here. I'm not going to link it. I'm just going to type Event and then Enter. And then I want one over here that says Probability. So I'm going to go to Layout, Axis, Vertical, and I'm going to click this way. And I'm just going to start typing probability and then enter. Ooh, I'm going to click here again and then type probability. I got that right there. I'm going to delete that. All I wanted was the word probability there. That was kind of ridiculous right there. Notice in 2007 you can scroll that formula bar there. So there we go. That just is a nice visual portrayal of all of the probabilities for all of our events, all equaling 1. Each individual one is between 0 and 1 inclusive. This visual portrayal will be the starting point for next chapter when we talk about probability distributions. Now I want to do a couple more things here. Let's see if I can scoot this off to the side. Now I want to, here we calculated these events here, right? By adding them up from the original sample points. But now I want to calculate the probability of a few things. And this is kind of the one of the tough things in this chapter is when they throw this at you. If only I could spell right. Now, and we haven't even gotten to the adding rule, which we'll get to in just a moment. But I can't resist because this is the one thing that people always miss. At least one head. So our probability, the question is asking us, hey, what's the probability of getting at least one head in 3 tosses? Hey, it's just English. At least one means 1 or 2 or 3, 1 or above, right? So the way we're going to do this, and we'll officially learn the rule later, is to just add them. Now, there's no overlap between these, which later we'll learn is called mutually exclusive. So we can simply add. And what does it mean? Well, we got a 0 here, right? But here's 1, here's 2, here's 3. So at least would be just adding them all up. So I'm going to Alt equals, adding them all up except for that one right there. Now, I want you to notice something. Later, notice the only one we left out was that one, right? So another way to do at least one head in 3 tosses is to say the sum of all of them minus that one particular one. So when only one of them is left out, you can do what's called the complement rule. 1 minus, and I'm going to say that one right there. They both get you the same thing. Now I want to look at, go to our next sheet right here, dice. Now, calculating, I didn't mean to have that there. Here's our experiment. Roll a die twice. Number of steps, even though it seems like there's only one step because you're rolling both with one hand, it really is 2 steps. You're rolling 2 die, you're rolling one, and then the other. So there's 2 steps. And how many outcomes are possible each time? There are 6. So how do we calculate the total? It simply equals 6 times 6. Now, that's the same each time, so I'm just using that same one, and we get 36. Now, listing the sample space for this gets a little bit tedious. So here's a great trick, and there's some homework problems that will involve this. Now, I'm going to highlight this like this and make it a little bit bigger. Now notice what I've done is I've listed the die 2 and the die 1 here. Now, and really what we want is we want 1, 1, and then over here we want 6, 6, 6. This is listing all of the sample points to create this list of sample space. Later we'll do the same trick and add, because we're going to want to add. But instead of typing this all out, here's another method. And so here it goes, equals this one right here. And now I got to show you a little trick here. If you hit the F4 key, all we've talked about in this class is that's called a relative, and that's called an absolute cell reference. So when I hit the F4, it puts 1, 2 dollar signs. One is for the column, one is for the row. But if you hit the F4 key again, and in fact, if you keep hitting it, it's a toggle key. It toggles between all of the cell references. And since when I copy this down like this, I want it locked on the number 1. But when I move it over to the next column, I want that little dancing ant blue to move over to the 2. I leave the dollar sign only in front of the row and not in front of the column reference. Right? So that would give me, just to show you what this would do, Control Enter, double click and send it down, and then copy it over. Notice it did exactly that. It locked it all the way down here, but when it moved across the columns, it moved. Control Z, Z. Now, that's not really what we wanted to do. We wanted to do our text formula here. So I'm going to, in quotes, open parentheses, end double quote, ampersand. Oops, I got a mistake there. And then I need an ampersand, double quotes, comma, space, double quote, ampersand. And then finally, I need this one. And this one is the opposite of this. We want the number 1 to be locked when we copy the formula across the columns, but not locked when we copy it down across the rows. So when I hit the F4 key, I hit it 3 times, dollar sign just in front of the column, but not the row reference. Finally, ampersand, double quote, close parentheses, double quotes. So all of you in this class, it's not required to know how to do this. Generally, mixed cell references is above the scope, Excel scope of this class. But there it is. I had to show you. For those of you that want to know, Control Enter. And then you can double click and send it down and over. Now, if that doesn't seem like magic to you, I don't know what is. So there you go. That's a quick way to do it. Now, in some of the problems, you'll have to add up, because you'll be trying to find the probability of getting a 6, for example. So the quick way to do this, again, we can highlight all the cells in advance and just put our formula in one cell, is equals this one, and I'm going to hit the F4 key twice, plus this one, and I'm going to hit the F4 key 3 times. That formula adds. This one up here, we are creating a label, sample points in the sample space. But this one may be a lot more practical, right? When I Control Enter to populate all the cells, just like that, I get at the intersection of any column and row, I get exactly what I want, which is the sum. So you can see when you do this, you get a 9, 9, 9. And now you can start to calculate the probabilities of getting a 9 when rolling 2 die or some dice. What's the probability of getting an 8? Well, there's 1, 2, 3, 4, 5. 5 out of 36, and so you start to get the idea. All right, our next topic, I want to go over to C, which stands for combinations. Now, in our last video, we did the combination rule and the permutation rule. I just want to review how you do that in Excel. Fact, that's factorial. Remember, 5 factorial equals 1, 2, 3, 4, 5. So equals 1 times 2 times 3 times 4 times 5. Right? That's the long way. You don't want to do it that way. It's 120, but you get the idea there. Factorial equals factorial. Oh, I can't type. That's a function. In Excel, it is programmed to calculate a factorial. So there it is, factorial of 5, 120. Now, in our example just a moment ago, we did, well, we already did this one over there, and we did the product function. This was our flip a coin 3 times, number of outcomes each time. So we, our counting rule for multi-step was simply to use the product function to multiply all the outcomes. Combinations. Remember, we had 12 total people on the basketball team, Che Dawson's basketball team, and he wanted to figure out what the combinations for team size of 5 were. Instead of doing it that big, long, write out all the math by hand, we're going to use the combin. And it asks for a number and number chosen. So the number is the bigger one, and the number chosen, or the subset, is going to be our 5. Permutations. Now, remember, this means that order doesn't matter. If you get 5 players, they can be on that team in any order. The other way to think of that is if you have 2, 1, that is, and 1, 2. Combinations consider these the same, so you get a count of 1 for both of these. However, permutations, these are considered different because order matters, right? 2 and 1 is different than 1 and 2. So when we get to permutations, if you wanted to find out all of the permutations for this team, you'd use the permut function. Number is the total number, and the number chosen is our 5. This is going to be a lot bigger number, 95,040. One last example for combinations. We talked about how the combination rules allows us. In our last video, we saw how we had some boomerangs, and we wanted to pull from this set of boomerangs. There's only 4. We would like to find all possible combinations of sample size 2 from a population of 4. Later, we'll use this with the central limit theorem. So this is just an example for combinations. All combinations of sample size 2, use our combin. 4, 2, and then enter. We get 6. Now, I want to try and list all of these experimental outcomes. I'm actually going to highlight these right here and right-click Hide. So, and the way you do this is just brute force, right? I'm going to put a B here because I'm going to start with a B, and I need to combine the B with a C, B with a S, B with a D. You know, when you're out there doing stats, you're not going to be doing this, but as you're learning it, my heavens, is it helpful to list the sample spaces and see how many total sample points there are. Well, the rest of these we can just copy, right? So we get a BC, a BS, a BD. That's done with the B. Now let's move to the C. Now, combinations, I can't go CB because I already have a BC. So now it's going to be CS and CD. So I'm going to highlight both, type C, and then Control-Enter. Highlight these two, copy and paste. Finally, once we do our CS and CD, we go down to our S. We can't go up to SC and SB because we already have those listed. So now all that's left is SD. So listing all of the experimental outcomes, the sample points for a combination, is a little bit easier. Now let's do permutations. If we were going to do all the permutations, it would be permut 4, 2. Oh, 12. Uh-oh. So this is 12. Now I'm going to highlight. Notice it says 5 and 12. I'm going to highlight both. This is how you unhide, and then right-click Unhide. And now I've grouped these, so I'm going to click this collapse button. That's what this means right here. So now I can maybe get to, I'm going to have to, I'm just going to undo that and hide all of these except for from there to there. And then right click hide. All right, let's see if we can list them all. This gets a little bit more tricky. I'm going to put my 3 B's. I know I can do this first one, right? So I got BC, BS, BD. Now I come down to C, and we still have to match it up against all of the other 3. Even though there's a BC, we need a CB. So I'm going to highlight all 3 and type big C. And then I need a B, an S, and a D. So I'm going to type a B, an S, and a D. So so now I've done the B's and the C's. Now on to the S's. So I need 3 S's. S. So and then I need a B, C, and a D. Finally, I'm done with the S's, so I come down to the D's. I'm going to highlight all those in D, Control Enter. And now I need B, C, and S. All right, so permutations, that's listing all the experimental outcomes from permutations. You can clearly see that there's a BC and a CB. You can clearly see that there's some BS, but there's also some SB. All right, now that's the end of this video. We're going to next video go back to our PDFs and talk about a bunch more the rules, adding, complement, multiplying, rules for probability, and then we'll come back and do that kind of stuff in Excel also. All right, see you next video.